Equilibrium and elasticity. This is an exceptionally brief green sheet lecture because there's basically nothing new to introduce. This is a 100% applications unit. The goal is to learn about how to analyze an object that needs to stay in static equilibrium. Box number 1 describes the requirements for equilibrium on the left. There can be no net force and no net torque. It doesn't mean there are zero forces or zero torques acting on an object. It just means that the net force has to equal zero and all of the torques have to sum up to zero. If the conditions on the left side are met, the object is in equilibrium, meaning it's not accelerating whatsoever, either linearly or rotationally. Box number 2 basically says if the momentum is zero, that means there's no velocity, and no velocity means no acceleration. So if you combine boxes 1 and 2, those are the conditions for true static equilibrium. Box number 3 provides a really complete equilibrium recipe. It's basically the force analysis method with a few other insights and tactics added. Box 4 is a reminder that the center of gravity or center of mass is the point at which all of an object's mass can be considered to be concentrated. At current time, we're not going to cover elastic properties of solids. Most of you will take a class called Engineering Materials or Engineering Statics, where you study both static equilibrium and material properties. Sometimes those are combined into a single class, sometimes those are two separate classes. In this class, we're just going to stay focused on static equilibrium. If you take advantage of everything specified in the Chapter 12 game plan, this will be an easy chapter to understand as far as problem solving. On the other hand, plan to spend a very significant amount of time practicing problem solving. The overarching concepts and strategies are pretty darn clear. In fact, I've summarized them already, but the problems themselves can be pretty challenging and you'll have to get pretty creative and again spend a lot of practice time getting good at solving them.